Good afternoon once again. Good afternoon once again. The exam is still ongoing. I have decided to extend it until tomorrow. There are those who haven't taken it yet, even for the first time. No, may iba na hindi. The others have taken it not even once. Who just came in? Lim is there. So there are those who need to take a second or a third try to get a higher score. Okay, the passing score is 55. Okay, that's about 11 over 12 over 20. Okay, any questions?
Sir, present po ako, sir.
May knows that? Sino yan? Sigalyawan.
Ako po, sir.
Dala lang, hindi ko makita. Last name, please. Pungase, last name. Banggud ang Galyawan. Next time, no? You log in with your last names first, so that it will be easier for me to trace your, ano. Okay? Please chat me, no? Dumandan, you're here. Okay. Save this first. So the exam is still ongoing, the second formative assessment. I'm not going to discuss it yet because there are people who need to take a first try, you know. Then there are those who need to retake for a higher score. The passing score is at least 11 or a 55, no? It's better if you get a 12. Make sure you get a 12, no? So any questions so far? So for the moment, I'd like to introduce a new topic. Okay? Any questions? No? So the next topic that we are supposed to discuss is Boolean algebra. This is very much related to Boolean arithmetic, no? In Boolean arithmetic, we learned how to represent numbers, no? Positive or negative, fixed point and floating point. We also have learned how to add, no? And subtract numbers. Okay, and then in the next topic, we will learn how to use this Boolean arithmetic concepts, okay, to build hardware. Okay, to build simple computer hardware, no? The very basic. No? So before that, we will be introduced the components, no, of a computer hardware, which is logic gates. Now, I'd like you to install a logic simulator, which we are going to use, no? Okay, and then you watch this video. Do you follow the Cedar Logic intro? How to use Cedar Logic. I'm also going to discuss this thing in passing, no? When we look at logic gates, no? They follow? Armayan, next time you log in with your last names first. Okay? No? So we will not be discussing the exam yet. Anyway, it's postponed. Let me just make sure that the is also postponed, no? The solutions, you pass your Excel worksheet. So before you log in now, next time you watch for the messages in the chat. No? Maybe I've forgotten to extend the deadline. Okay. The deadline yes, the solutions, okay? Wala na edit ito. Okay. Let me do that quickly, no, before I forget. Extend no. We have a lot of topics already. Huh? Extend the deadline for the solutions, no. Pass your solution here, no, as worksheet. So very slow, no? So let me just do that next time, no? Okay. So logic gates and Boolean algebra. What are logic gates? Logic gates are electronic components that are used to build the basic unit, no? The basic unit of a computer, like ALUs, no? CPUs are built using logic gates. What's Boolean algebra? Now, Boolean algebra is like decimal algebra, except that its main purpose is used to design logic circuits. Okay, Boolean algebra is useful because before uh, before any hardware is built, they undergo through a design process called Boolean simplification, in which Boolean algebra is very much useful. Okay, do you follow? Let me use do I have an updated version? Okay. Hindi pa natin kailangan ng, do we have, yeah. We may need to take Boolean simplification later, no? But, no, it's not included. Okay. So, this set of topics is enough, no? Any questions so far? So, good afternoon. Nag-attendance po ako. Armayan, yes. Sa Zoom meeting because of my net connection. Okay, next time, I also held your, your entrance to our room because you're not logged in properly. So you log in with your last names first, okay? Okay. So I get to check your attendance much easier now. So digital systems are said to be constructed using three basic logic gates. These are used to implement Boolean arithmetic. No? It's called logic because there are only two states, no? 0 or 1, or Boolean. It's Boolean, it's either true or false. So it's called logic because it's either true or false. The output of a logic gate is either true or false. That's why it's called logic gates or Boolean gates. Okay. So these gates are and, or, and not. Now, we may represent them in a symbol. This is the same symbol that we use, no, to represent them in a circuit. Okay, for example, AND gate. This is the symbol of an AND gate with a rounded. It's like a rounded rectangle, a rectangle with one end being rounded or curved. Okay, so there are two sides of any gate. An input side, which is the straight side. Now we can invert. Now in this case, the input is in the left side and the output is on the right side, but we can invert this, no? Because the rounded edge represents the output. Okay, the straight edge represents the input, which means that a logic gate does a function. Okay, it performs a mathematical function. It has an input and it has an output. All logic gates can have one or more inputs and can have one specific output. For example, we say A and B. A and B is also written in multiplication form. So A times B is also A and B. Okay? Diba? Because times in Boolean arithmetic is actually also and. When you say 0 times 1, that's 0. 1 times 1, that's 1. Diba? So 0 and 1 is 0 because 0 times 1 is 0. 1 times 1 and 1 is 1 because 1 times 1 is 1. But 1 times 0, or 1 and 0 is 0 because 1 times 0 is 0. Do you follow? So the AND gate is an electronic circuit that gives a high output or a 1. When we say a high, we also mean a 1. If all inputs are high or all inputs are 1. A dot or multiplication is used to show the AND operation, A dot B, like that, or A just A and B. Okay, any questions so far? No, that's an AND gate. We will use, no, a circuit simulator called CIDAR logic, in order to build circuits here. No, okay, any questions so far? Okay. Okay. So, sino yung kung kalapit dumanda niya? I've checked. So anyway, no. So the next AND gate, sumubra, no? Sorry, I think I so fast. It's called an OR gate. The main difference in the symbol is that slightly curved. The input side is slightly curved and the output side is pointed. Okay? Unlike in an AND gate, the output side is pointed and the input side is curved. Okay? OR actually represents plus. Okay? Parang plus siya. Because the logic states that if you have 1 plus 0, that's equal to 1. 1 or 0. When you say an OR, when an input contains a 1, it automatically becomes a 1. No? The output automatically becomes a 1. 1 or 0 is 1. 0 or 1 is also 1. So that's why you have 0 plus 1 equals 1. 1 plus 0 equals 1. But what will happen if you have 0 plus 0? That's 0. And what will happen if you have 1 plus 1? That's also 1. Do you follow? Diba? Okay, 1 plus 1 is 1. Although we know that there's a carry, no? The OR gate is an electronic circuit that gives a high output if one or more, or at least one of its inputs is high. Okay, a plus sign is used to show the OR operation like this. Any questions so far? The NOT gate. So the NOT gate is a bubble. It's like an AND. The NOT is an inverter. It's like a flip. No? It will flip a 0 to 1 and a 1 to 0. Okay? It is used to do or to transform one's complement. Okay? It's also called an inverter. Okay? Any questions? So usually a NAND is a NOT is a bubble. When you say A equals NOT of B, A is the invert of B. Okay, which means that if B is 0, A is 1. If B is 1, A is 0. One's complement, in other words. No? There are other gates, no? A combination of gates. NAND. A NAND is an AND followed by a NOT, not followed by an AND. Do you follow? Any questions so far? So, what will an AND 1, 1, no? An AND will have a 1, 1. So, a NAND gate will have a 0, 1, 1, 0, okay, and 0, 0. Okay, because they are the inversion of a NAND. A NOR. What is a NOR? A NOR is a NOT of an OR. So if an OR will have a true if you have 1 or 0. 0 or 1 and 1 or 1. So a NOR gate will have a true if you have 0, 0 and 0 for A and B. Do you follow? Because it's the invert of an OR. Okay. Another logic gate is an EOR or an XOR, sometimes called an XOR. It's an exclusive OR. It's like an OR gate. Okay, so this is the symbol, no? It's a plus inside the circle, and this is an XOR gate with a double curve on its input, double curved line on its input. Okay, the main difference between an EOR and an OR is that exclusive. The EOR gate is exclusive. Only one of which input is high. So 1 E or 0 is high. 0 or 1 is high. CU E or 1 is high. But 1 E or 1 is 0. Okay, because only one of them should be high at the time. Okay. Okay. Any questions? No? Simple gates, no? So this is a summary of all symbols. You have an AND gate, an OR gate, a NOT gate, a NAND gate, a NOR gate, and an EOR gate. Or an XOR gate, sometimes called XOR, for exclusive OR. EOR or XOR, no? Any questions so far? Now, how do we represent logical expressions or logic gates? One way to represent a logic gate is using a truth table. Is there such a thing as a truth table? Can you table the truth? How can you table the truth when it's so complicated? You cannot table human truth, no? But you can table Boolean truth, because Boolean truth has only two states, 0 or 1, true or false. Do you follow? So when you say truth tables, we refer to Boolean truth tables, which means they are the truth tables that can enumerate all Boolean logic. Do you follow? It's easy to enumerate Boolean logic because it only results to 0 or 1 or 1 or 0. Okay? Any questions so far? It's a breakdown of all possible values that a function can attain. Okay? So it's a map of all possibilities that a logic expression or gate can generate. Okay? Any questions? So for example, here are the truth tables. No? How do you generate a truth table? You do a binary series. No? The rows of a truth table is a binary series. For example, this is the first row is 0, 0. The second row is 0, 1. That's 2. The third row is 1, 1. No? The third row is 1, 0, which is 2. The last row is 1, 1, which is 3. So 0, 1, 2, 3. So this is a binary series. Okay, excuse me a while. No? Excuse me. I'm sorry for the disturbance now. Okay. So where are we now? Itong truth table, no? So this is a Boolean series. This is 0, 1, 2, 3. So you can see the AND. Okay. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. That's the truth table for AND for two inputs. Any questions? Or the truth table for OR. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. So the NAND is the opposite of an AND. So if AND is 0, the NAND is 1. If AND is 0 here, the NAND is 1. If AND is 1, the NAND is 0. Do you follow? No. An OR is also the opposite of an OR. So as if OR is 0, NOR is 1. Okay? If OR is 1, NOR is 0. Now take note of the EOR gate. The EOR gate is like an OR gate, except at the last, where 1 or 1, EORs, 1 E or 1 is 0. Because only one, there should be only one 1. No? The count of ones should be odd, not even. Okay? 2 ones is even, so the EOR will result to 0. Remureras. Okay? Any questions? So the truth table. Properties about Boolean truth table. You have to familiarize this. No? The input of size k. Okay. If the input size is k, for example, the input is 2, which means there's an input of A and B. Okay? And or if the input is 3, you have an input of A, B, and C. Do you follow? A, B, and C. So k means the number of inputs. Given an input size k, the number of a truth table b to the k is b to the k. Do you follow? We have this in our previous topic. No? So for example, if there are 3 variables, 2 to the 3, b is 2. There will be 8 rows because 2 to the third is 8, which means you can also count, no? 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. There will be 8 rows in the truth table. Okay? So that's the number of a truth table. The total number of rows that can be present in a truth table. What's a mean term? A mean term is a product term, sum of products. Now we will have an example on this. That has all variables and that will evaluate to 1. We'll give examples. A max term is like a mean term, but this is is a sum term. No? We'll find out why. No? A Boolean function is a mapping of k bit strings to either 0 or 1. Let's have an example. No? For example, this is a Boolean function. Y is equal to AB plus A not B. So this is like an algebraic function, right? But our variables can only assume value 0 or 1. Unlike in simple algebra, our variables can have a wide range of values. No? Do you follow? Do you follow? Okay. Okay. So this is our Boolean example. Y is equal to A and B plus A and not of B. The tilde before, it can be a tilde or an exclamation point. No? When a tilde is used, it's used before, not of B. Do you follow? Everyone? Okay. So this is the Boolean table of this expression. Okay. You have 0, 0. Okay. Y is 0. 0, 1. Y is 0. 1, 0. Why 1, 0? Because A not B, where A is 1 and B is 0. So this is 1. Okay. Each term is called a product term. Okay. A product term because A and B are product. A and not B is also another product. Okay. This is the sum of products form. Okay. Because there's a plus and the plus adds each product. we have two terms, no? It's like simple algebra, no? And the last term is AB, 1, 1 is 1. Do you follow? Do you get this truth table? The truth table of a function y. Okay. Any questions? Any questions so far? No? So that's the truth table of a simple function. Now, if you say a mean term, okay, these are two mean terms, no? It's sum in this. Its term is a mean term. This is a mean term. 1, 0 is a mean term because it has the variables a and b. Okay, 1, 1 is also a mean term because it has all the variables a and b. Okay, AB is a mean term, A not B is a mean term, but A is not a mean term, no, because it lacks B. So these mean terms are actually rows in a truth table that evaluate to 1. So how many mean terms do we have here? We have 2 mean terms because we have 2 rows that results to 1. Okay. What are the standard forms that you can write a Boolean function? It's like standard algebraic form. The first form is called the sum of product. It's also called the mean term form because it's the sum of terms. Okay, so this is a mean term form. Y is equal to AB plus A not B. The products of sums, the other way to write a Boolean form table, rather function, is in product of sums, where we have, okay, the product of sums. Each term is a sum, not a product. Okay, do you follow? So this is called a max term form. A plus B, the equivalent is A plus B times quantity A plus not of B. Okay, this is the SOP. These are the same functions written in two different forms. One in sum of products, the other in product of sums. Okay, any questions so far? No? Another way to express a Boolean function is called a K-map. Okay, what is a K-map? A K-map, a table is a table form. No? A K-map is a grid form where you have columns and y's. Like for example here, this is the truth table of the function y is equal to AB plus A not B. In the K-map form, you use a grid where B is on the columns and A is on the rows. So this is A is equal to 0, B is equal to 0, this is 0. Because we have A is equal to 1 and B is equal to 1, this is 1. And A is equal to 1 and B is equal to 0, this one. All the rest are zeros. Okay. Now, you may ask, what's the use of Carnot maps? Carnot maps was invented by Maurice Carnot in 1963. No? It is used to simplify Boolean functions. We will not be doing simplification here anymore. No? You will take that up on a different course later, no? In Boolean logic, where you will have everything Boolean. Okay. Any questions so far? Truth tables and Carnot maps. So let's look at them, the min terms and max terms in the truth table. Now, max terms in a truth table are those that evaluate to 0. Do you follow? Min terms are those that evaluate to 1. Can you see that? No? And in a K-map, those squares on the grid that result to 0 are the max terms. The squares that result to 1 are the min terms. Okay? So naming pa lang tayo, jargon. No, kumbaga we are just knowing the jargon. No? Because everything difficult lies on the jargon. Once you know the jargon, everything is easy. Okay? Do you follow our jargon? No? Min terms, max terms, truth tables, the number. No? Okay, the number of a truth table, the number of rows. When you say the number of a truth table, we refer to the number of rows possible on a truth table. Okay? It's just jargon. Okay? Any questions so far? Boolean algebra. It's the mathematics of Boolean numbers. It's just a math. It's not just a math. It's used for logic design. It's used to design computers, calculators, and others. No? Okay. The basic laws of Boolean algebra will be implemented as switching devices called logic gates. Okay. Now, when you have a network or a connection of circuit of logic gates, you can use them to manipulate signals Like you can perform more numerical operations such as addition and multiplication. Do you follow? It's not just simple algebra. We use this to build circuit that can perform other functions. No? Translations, for example, no? From one binary code to another. This can also be done by Boolean algebra. Okay? So hindi lang tayo x plus y dito, no? X is equal to look for the value of x and look for the value of y. No. We are going to use this to build computer circuits. Okay? So a Boolean variable, the domain, this is called the domain of a variable. The main difference of a Boolean variable and a simple algebra variable is Boolean variables has a limited domain, have limited domains, only 0 or 1. The possible values of a variable can only be 0 or 1, either true or false, high and low, or on or off. Okay? Do you follow? Can you say it's much easier? Not at all times, no? There are Boolean functions that are difficult to figure out, no? The basic operations of Boolean variables are not, and or, also referring to the basic logic gates. But we can perform more complicated Boolean functions from basic Boolean operations. No? We can perform a lot, no? Like, the operations that convert a file into a graphic, no? Into a map, like an MP4, no? And so on and so forth. Okay, it's not just easy, no? Okay, any questions so far? How do we derive canonical forms or standard forms from a truth table? Given a truth table, how do you write the expression in a standard form? Okay, usually we are given a truth table first, then before the function. Okay, so we will write, given a truth table, we will write the min term and max term. So remember that a min term is a value in the truth table which is 1. Okay, take the normal form of the variable. If the value of the truth table is 0, take the complemented form. No, let's have an example. No, for example, we have here the min term form. From the truth table, we have 0, 0, 0. The min term is not A, not B. Why? Because it's complemented. A is 0 and B is 0. We will take the complemented form. So not A, not B. That's the min term form. Now, if A is 0 and B is equal to 1, we'll say not A, B. Why not A? Because A is 0 and B is 1. Okay? When you have A, not B, you say A, not B because A is 1 and B is 0. And you have AB because A and B are both 1s. Do you follow? That's the min term form. How do you write the min term form? Okay? Do you follow? We take the complemented form when we write the min term form. But when we do the max term form, we do the opposite. When A is 0, we do not complement. Okay, like here, the max term form of A is equal to 0 and B is equal to 0 is A plus B. There are no nots because it's the reverse of min term. Okay, so in this case, we have A plus not of B because A is 0 and B is 1. In here, we have not A plus B because this is A is 1 and B is 0. And the last max term is not of A plus not of B. Now, the max term is usually written as capital M. No? The min term is small m. So do you know how to write the min term and the max term now? Okay. For example, we have this. No? Okay. We have the same truth table. So, dito sa min term form, in the min term form, we will look at the values that are ones. No? So, the min term form is A not B plus AB. So that's why you have AB plus A not B. We can inter-reverse them. We can reverse them. Now, what's the max term form? We will look at the rows which are zeros. So this will be AB plus A not B. So this is AB plus A not B. Do you follow? So these are the two ways of writing a function from the same truth table. Now we can say sigma is the summation function in Excel, right? And phi is the phi. Is this sigma or the what's that? Delta. But this is the multiplication, no? Which means that y is the sum of m2 and m3. Why m2 and m3? Because in our truth table, I'm sorry, slideshow. In our truth table, no, A, B, and A not B are M2. This is M2, this is M3. Okay? And sigma ito, no? Ito is phi M of 0 because it is the products of M0. This is AB and M1, A not B. Do you follow? Okay? How do you derive a mean term and a max term? We will have exercises in this. No? Laws in Boolean algebra, maraming kulang, may kulang ito, no? But I will introduce that to you later. No? Basic laws. You must understand this. Commutative law of addition. Okay? So meron tayo nito sa algebra, right? We also have this in Boolean algebra. When you say commutative law, both or and multiplication and addition are commutative, which means that x plus y is equal to y plus x. Or x and y, or x times y is equal to y times x. Remember that plus is also an or. So when you say x or y is equal to y or x, x and y is equal to y and x. Do you follow? Associativity law of or and and. Okay. X plus y, quantity x plus y plus z is equal to x plus quantity y plus z. It doesn't matter whether you do left and right. M dash din ito, no? M dash. So M or and is higher priority than or, no? Okay. X times y, quantity x times y times z is also equal to x times quantity y times z. Okay, associativity law of addition or and, or in algebra of addition and multiplication. Okay, distributive law. This is valid in normal algebra, no? A times quantity b plus c is ab plus ac. Pareho lang, it's the same algebra, same math. No? When you say simple, same algebra, okay, or same math. Now, there's a dual, no? When you say a plus b times c is equal to a plus b times a plus c. This is only valid in Boolean algebra, not in normal algebra, no? Okay? Do you follow? You can distribute, no? You can distribute multiplication. In algebra, or rather in simple algebra, you can distribute multiplication but not addition. But in this case, you can also distribute addition only in Boolean algebra. Okay? Any questions? No? Boolean algebra lang yan. Identity law. You must memorize this. X plus 0 is X. Anything ORed with a 0 is itself. X times 1 is X. Anything ANDed with a 1 is itself. Okay. X plus not of X. Not can also be written like this. Is always equal to 1. Because one of them is a 1. Anything ORed with a 1 is a 1. X of not of X. X and not of X is a 0. Because anything ANDed with a 0 is a 0. And one of them is surely a 0. Any questions? Okay. So my principle of duality, no, it's like one's complement. Okay, there's a principle of duality between POS and SOP, between mean terms and max terms. Okay, if two expressions are equal, then the duals are equal. No? These are helpful in remembering the Boolean laws. No? For example, we have this. These are the dual of the expression. No? X plus 1 equals 1. The dual in POS form or max term form is X times 0. So ganito yon. A plus becomes a times and a 0 becomes a 1. And a 1 becomes a 0. When you say X times 0 is equal to 0, what is the dual of this expression? X plus 1. The times becomes a plus. But the 0 becomes a 1. Do you follow? Diba? X plus X equals X. X times X is also an X. Do you follow? Because there are no zeros and ones. X plus not of X is equal to 1. It's the same thing. X times not of X equals a 0. Do you follow? No, dual sila. Mean term expansion. For example, you are given an expression. We want to look for the mean terms. Now, there is this a shorter way. This is a long process. No? Okay, medyo mahirap. Anyway, I'll discuss this next meeting, okay? Can you study this yourself? Okay? Kasi mahaba ito eh, no? Given a function, let me just try to introduce this to you, no? How do you convert? Given a function, how do you convert? How do you find the mean term? The list of mean terms. Okay. This is a process that is used to locate the mean terms given an expression so that you can locate the mean terms or the rows in the truth table. Okay. For example, derive the mean term of the expression f is equal to not of a plus bc. Not of a is not a mean term because it doesn't have b and c. BC is not a mean term because it lacks a. A mean term must have all the variables. Do you follow? So how do you do that? Convert A and plus BC to sum of products or canonical form. Now, how do you convert not A to a mean term? You multiply it with B plus not of B and C plus not of C. These are ones, no? B plus not of B is 1. C plus not of C is also 1. So multiplying anything with a 1 is still a 1. Do you follow? Do you follow? Since A lacks B and C, we multiply them with B plus not of B and C plus not of C plus BC. Now BC lacks A. Do you follow? So we multiply it with A plus not of A. Do you follow? Kung ano lang yung kulang. Whatever is lacking, we multiply it to the term. So now we distribute this. Not of A times B is not of AB plus, we distribute not of A BC. Now we have C plus C. And then we distribute A, B, C, and then we distribute to not of this becomes this. And then the C plus not of C we will distribute. So we have not of A, B, C plus not of A, B plus not of A, C. And now take note, not of A, B, C occurred twice. Okay? Not of A, this one, no? Not of A, B, C occurred twice at the beginning and the end. We can combine them because X plus X equals X. Do you follow? So we can combine. So combining them, we now have not of A, B, C plus not. Now they are all mean terms, which means we can now locate them from the truth table. Okay? Okay? Any questions so far? I'm not going to give you an assignment on this muna, no? Although there's already an assignment to do. But if there's an ongoing exam, so I'll spare you from the assignment. Derive the mean term form. F is equal to ABC plus A not B plus A not plus not AC. ABC is a mean term, but A not B is not, and not AC is not. Okay, so what will you do to convert this into a mean term? We multiply this with C plus not of C. And this not of A times C is converted by multiplying with B plus not of B. Do you follow? Okay. So mean term expansion for A not B is A not B is equal to A not B plus this. So you will have this A not BC plus A not B not of C. Okay. So dapat this is not new algebra, okay? It's just a simplified form of algebra, okay? A not C, we'll multiply it with B plus not of B and distribute. So we'll have this and we add them together and we combine like terms. So we'll have ABC plus A not B. And then we can locate them from the truth table. Do you follow? Okay. How do you convert into max terms? For example, derive the max term A plus A plus B. So we only have two variables A and B. A is not a max term because it lacks B. A plus B is a max term. So what we'll do, we'll add it with 0. Okay? For min terms, we multiply it with 1. For max terms, we add it with 0. B plus not of B is a 0 man. Okay? Therefore, we can have A is equal to A plus 0 or is equal to A times B of not of C. So this will become, okay, ang A will become A plus B because we are going to distribute A plus B and A plus not of B. Do you follow? This is just A alone. Okay? So we will now substitute it here. We have A plus B plus A not of B plus A plus B. And then we can combine the like terms. Look at that. We have two A plus B's. We can combine them. And now we have A plus quantity A plus B times quantity A plus not of B. We now have both max terms. Do you follow? Okay. Now let's look at that. No? No? In the truth table. So this is 0, 0. This is 1, 1. Look at that. This is still the same mean term. No? These are the max terms. 0 plus 0, 0 plus 1. Because 0 plus 0, this A plus B. 0 plus 0, ito 1 plus 0 plus 1. So 0 plus 0, 0 plus 1. This is it. That is it. 0. Do you follow? Okay. And this we have 0 plus 0 plus 0 and 0 plus 0 plus 1. Okay, that's 0. How about this? This is 0 plus 0 also and 0 plus 1. The same thing. They're just inverted and then we have a 0. And we'll have compute this 1 and 0. This is a 1 and 1. Look at that. In the truth table, the max terms are zeros. Do you follow? Do you follow? Okay. How do you convert the SOP to POS? Madali lang. We use the truth table, no? Okay. So for example, this is our our function. Not A times not of B times not of C plus not times this. These are mean terms, right? How do you convert them into POS? We look at them at the truth table. No, these are the rows. 0, M0. Sorry. This is 0, 0, 0. That's row 0. 0, 0, 1. That's row 1. 0, 1, 1. That's row 3. So this is all. These are the rows in the truth table that are equivalent to 1, which means the rows that are not here are those that are equivalent to zeros, which are actually the max term. Do you follow? Do you follow? So anong wala dito? This row 2. Row 2 is not here. Row 4 is not here. And row 5. So 2 is 0, 1, 0. 4 is 1, 0, 0. 5 is 1, 0, 1. So we find the complement. That's always the way. No? So 2 is 1, 0. The complement, the ones complement. Because the max term is the ones complement of the mean term. No? The ones complement of 4 is 0, 1, 1. The ones complement of 5 is 0, 1, 0. So therefore, we just convert this. 1, 0, 1 is A plus not of B plus C. Okay. 0, 1, 1 is not of A plus B plus C. 0, 1, 0 is not of A plus B plus not of C. Do you follow? So this is the mean term form. This is the max term form. Do you follow? Do you follow? No? Any questions? So next meeting, I will give you exercises on this. And I'd like you to take a look at Sidor logic. Okay? Kasi ang Sidor logic is used to build. For example, let's look at our original expression. Saan ba yan? Ito, AB plus A not A. No. Okay? Do you follow ito? How do you compose a circuit like this in Sidor logic? It's like this, no? Sidor logic. Do you follow? This is Sidor logic. You watch the video. There's a video in our in our website here. Intro to Sidor logic. You watch this. This is a very good video. Okay. Okay. So ito, you have basic gates, you have invert and connect, you will have flip-flops, registers, we will not use that. We will have input and output. No? Ito lang gamitan natin dito, basic gates. No? So for example, we have AB. What's our circuit? AB plus A not B. We will build this in Sidor logic. Okay. AB ang AB. So we'll need an AND gate for A. Now usually we will have input output directions. No? This is a direction. No? And then we label it with A. Okay. Where's our label? Decorations text. This is our A. Okay. Ito yung A. And then we will have another text. This is our. We just double click, no? Drag it there, and then we have our B. Okay. Pwede na nawala ito. We'll just have to use that, no? Anyway, input and output. Now, when you click, this is a 0. When it's red, it's a 1. Do you follow? No. So now we are going to get a gate. We'll drag it here. And then we'll connect. Okay. Do you follow? And we have an A not B. So if you have a NOT, what you will have is, pwede pa ba tayo mag-connect? We'll need a NOT gate. We need another gate, an AND gate with an, where's an AND gate? 2 input AND gate. Nandun sa taas. Okay. Ang problema lang, lagyan natin muna ng NOT. No? So, do we have a NOT gate? Invert. Ito, no? Invert. This is the NOT gate. Okay, we'll connect this to, now we don't have a connector anymore. Can we still connect? Wala na, di ba? So we'll have a connector, a 4-point connector, no? Input output. We can have let's look at the connections. Invert. We don't have it here. Input and output. Where can we connect a 4? I'm looking for a connector, no? Do we have a connector here? I think this is a connector, no? Do you follow? We can cut this. Then we'll connect this. Ang agent. Now we now have a 4 input connector. So that we can make 4 connections because it is not of A, right? Do you follow? And then we'll cut this so that we can have a 4 connectors. This is the 4 connector. Do you follow? Okay. Do you follow? No. Okay. Not of A. No, this is not the not of A. This should go to the not of B. Dapat. And then we have A. This goes to AB. You can use this to construct the truth table. Do you follow? So this is an Sidor logic. Now you download and install Sidor logic. Okay, and then try the simple gates. Then we have input and output. We can put an output here. Okay. And then we need an XOR gate, right? Or rather an OR gate. This one. A plus is an OR. Take note, no? Put it there. Then connect it here, no? Do you follow? So AB. We'll put this A. Take note, 1, 1 makes it 1. Okay. 1, 0 is also a 1. Okay. 0, 0 is a 0. How about 1, 1? We just click, no, to make 1, 1 is okay, no? 0, 1 is a 0. Do you follow? Skalyo. Wala skalyo kay mali man yung login niya. Okay. Do you follow? So you play around with this. Now this is not a very difficult, no. So you just go to basic gates to pick the gate and gather it there. And then you can have connectors, no, ito. Connectors, you can have NOT gates. And then you can have input and output. This is your switch for the input, which you can make. A 0 is a black, a red is a 1. Okay? Any questions so far? Okay? So we'll do this again next meeting, no? Consider logic. For the moment, it's enough, no? There will be no problems to solve, but you will have a lot of problems to solve, no? This is another math, no? For the moment, no problem is going to be assigned because the exam is still ongoing, okay? So those who haven't taken the exam, please take the exam now, no? There are those who haven't taken even just one attempt, no? To take them now, you have until tomorrow at 12 p.m. midnight, okay? Any questions? So I'll upload this. Okay, next meeting we'll solve exercises. Okay, I'll introduce you to new exercises. Okay, and I'll introduce you to simple circuits. So those who need to retake the exam, you have until tomorrow midnight to retake the exam to get a better grade. You know who you are. You should be able to get at least 11 out of the 20 items. Any questions? Okay. So hanggang dito lang muna tayo ngayon, okay? We're up to this point. I'm going to give you exercises next meeting. And then if all people have taken the exam correctly, we will, okay, answer the test. Any questions? Goodbye, everyone. No? Okay. See you next
Bye,
time.
sir. Thank you,
Okay.
sir.
I'll upload this.
Bye,
Thank you.
sir.
Bye.
Bye po, sir.
Bye. Okay.
Bye,
Thank you,
sir.
sir.